Okay. We'll start the presentation. What we're going to do today is first we're going to get a little bit of theory on the electronics parts, which is going to be the crash course. And then right after that, we're going to do some calculations to find out what's the resistor value that we need for RGB LEDs. If you take a look at here, I got 1,000 RGB LEDs, which is very hard to get a hand of around here. And each one is like $3 to $5. So there's a lot of money invested in this 1,000 of them. I ordered them from the factory, but these are some of the coolest things that you can get a hand of, because you can do all kinds of colors with this. Some of you may have this already on your kits, and if you don't, it's an awesome thing to get it. Because you're here today live, each one of you are going to get at least one of them. So can you come and pass this out? And each one of you just grab a couple of this. Actually grab one for right now, and then when we do more experiments, we'll do that.
That's one each person?
Yeah, one for each person, please. Last week we did the Arduino, Introduction to Arduino, part 1. We talked a lot about the details of Arduino. There are thousands, not thousands, but I would say hundreds of videos on Arduino that you can go and look and see the introduction to the Arduino.
She says she wants to see a close-up of the LEDs.
Oh, close-up of the LEDs? Perfect, yeah. Any interaction we want to have as much as possible. This right here, can you see it? Can they see it?
Yeah, it's focused.
Focused? Awesome. And it's got 4 legs. We'll go into detail about this in a little bit. And we're going to light them up and all that. Thank you very much. Okay, so let me go ahead and start the Prezi. Prezi is a very awesome presentation software that I would suggest anybody that wants to upgrade from their PowerPoint, they can do it. And you'll see the power of it today. I've incorporated both videos and also schematics and drawings into this particular presentation. Before I get into the presentation though, there's going to be a lot of people that are going to be watching us, and they're going to be saying, what is this all about, where are you guys at, and so forth. So I would like to first introduce, for all those that are watching us from around the world and in Orlando, our Meetup page. Everything that we're doing is going to be announced in the Meetup page, and this is our Meetup page, which is Arduino, Electronics, 3D Printing, and Entrepreneurship. And we're here in Orlando, Florida, and we both have courses and workshops in Orlando and in Kissimmee. Right now we are at our Kissimmee location, and next week we're going to be in Orlando, and we're going to be at the Microsoft store in the Florida Mall. You guys been there before? We did one a couple weeks ago, and we're going to be back there. We're advancing from little basics to medium to very, I would say, high-end and also more challenging projects this year than last year. Last year we did about 30 workshops. Most meetups only meet like once a month, so they only do 12 a month. We did triple that amount, and we started back in March. The goal is to do one meetup workshop every week for every month. And the plan so far is to do two meetups in Kissimmee and 2 meetups in the Orlando area. And the most basic ones we're going to start in Kissimmee, and we're going to build up to the more advanced in the Orlando area. Any questions? Any questions from the audience? And do you see anybody asking any questions? Okay. How many people do we have online?
2.
2. Excellent. Okay. So Arduino, Electronics, 3D Printing, and Entrepreneurship, and we're in Orlando, Florida. And if you want to join us, just go to meetup.com and hit the join button, and you'll be able to get in there. Okay, let's start. I have a presentation here about LED lights in a lot of detail, and I think this is going to give you, each one of you, a very close look into the power of LED lights and what it's all about, and into the power of the Arduino board. The Arduino is a microcontroller, as you've seen before, and for those that are new, it's a small microcontroller. It costs anywhere from $25 to $30. Very affordable, but it's very powerful in the sense that you can connect things and control them. Things such as LED lights, motors, sensors, and really interact with the world around you. And what makes an Arduino board great, as we mentioned last week, is that this is the Arduino board. Let me unplug this real quick. Is that there's not only a board that is easy to access through these connectors, these headers, but also there's tons of code online, and that code is available to a lot of people, and you can look at the code and learn from others that have programmed this, and maybe copy and then modify it and make your own code, and it's open source. It's an awesome platform, an awesome starting basis to do robotics, to do all kinds of very nice and interesting projects. Okay, so let's go ahead and look at the presentation and see the LED lights, because we'll be using this Arduino board to control LED lights coming up next. And the type of LED lights that we're going to use is RGB, which is red, blue, and green. All three LEDs in one little unit right here. Okay. Any questions so far? So far, so good? Okay. There we go. Last week we talked about an RGB, an LED light. This is a simple one that only has one anode and one cathode, and basically it has a positive and a negative side. If you take a look at the RGB LED, we have 4 legs. It's much bigger than this one. It's because inside here we have several LEDs put together. So this is the symbol of just one single one that I have here. Imagine having 3 of those. That's what we have inside one of these. One red, one blue, and one green. And here is a close-up of it. There's 2 types of RGB LEDs. This could be very confusing for some people, because you go to the store and you just ask them, can I buy do you have any RGB LEDs? He goes, yeah, sure, here they are. You buy them and you realize you bought the wrong kind, or it hooks up differently, connects differently. So make sure that you get the correct RGB for your project. And there's one that's called common anode. Sorry, just time on this side. Okay, one is called common anode, and it looks like this. And then there is common cathode, and it looks like this. Now, can anybody tell me what's the difference? They look pretty much the same by the look of it. But what's the difference between common anode and common cathode? Yes?
The long pin versus what is referred to as the anvil, and that's the positive versus the negative. So if polarity is everything, polarity is everything.
Right. If you take a look at right here, the drawing, this long leg on the common anode is the common anode. As opposed to the common cathode, the long leg, as I'm showing right here, is the common cathode. So one is an anode, one is a cathode. And it matters a lot when you have to talk about the how you're going to connect this. For example, right here I have a little detail. Common anode, the positive is connected to the power supply. The other legs, RGB, to ground. So this one, the positive is connected to the power supply. So you only need one resistor right here, and the other ones go to ground to turn this LED, RGB LED on. So you only need one resistor on the positive, which is this big leg. Okay, that's on the common anode. Everybody got that? One resistor on the big leg that connects to positive. This other one, you need 3 resistors on the smaller legs, and this long leg connects to ground. So it's like almost the opposite, totally opposite. Here the big leg goes to positive with 1 resistor. Here the big leg goes to ground with no resistor. Okay? And then these other legs on the cathode have to have resistance because these are going to positive. Every time you go to positive, and I'm going to go and draw it right here so you can get an idea. This is going to be the positive and the negative, and this is going to be the resistor. Hopefully you guys can see here. You cannot connect LED directly to power because it would have infinite current and it would overheat and it would get damaged. So whenever you're connecting an LED, let's say this is the battery. This is the positive side of the battery, this is the negative side of the battery, and you're going to be connecting this to an LED. It's going to be right here. You need to make sure that you put a resistor on the positive side. And I'm gonna, this is a resistor. And then you can put your LED here. And I'm gonna put the LED in just a second as soon as we go through the chart. So this is the positive, this is the negative, and on the positive side, you gotta have a resistor that limits the current that's going into your LED. So we're going to figure out what value, what resistor value we need here in a little bit. And then I'm going to draw the correct LED that goes in there in a second. So it's very important that you know that, otherwise you'll be blowing your LEDs and they will not work for a while. So let's take a look with more details. Here is a little bit of a schematic of the common anode and common cathode. This is what we're looking at, actually. It'll become more apparent to you when you connect this into your Arduino board. Which of these two do you think we can connect? Let me go back to this. Which of these two do you think we can connect to the Arduino board? Can we connect a common anode or a common cathode? Which one of these will work? One of them will work better than the other, or one will work, the other one may not even work. What do you think?
Technically, you can make both of them work, but it was a matter of what do you got to do. In fact, not to confuse anybody, it is the fact that you can even take that part that's the common cathode that would go to ground, and you could actually hide the resistor in there, because as long as it's somewhere in the circuit to limit that current, you're good.
Yes. But if you want to have total control of the Arduino board, which of these two would you use? Would you use the one that you just need one resistor right here? Or would you use the one that you need resistors on each one of these positive, I would call them power lines?
3 resistors.
3 resistors, that is correct.
More configurations.
Yes.
And is that the cathode?
This is the common cathode, that is correct. So what we're going to use, we're going to use the common cathode. We're going to tie each one of these legs into a digital pin that is going to create pulse width modulation. First we're going to turn them on and off, and we're going to control each of the colors. So we're going to need 3 resistors. Very nice.
I have a question. How can you tell which one you have by just looking at it? Can
Well, it's hard to tell them by just the look. You got to look at the spec sheet when you bought it, and if you have it, you can just test it out. Put a resistor and see how it lights up. Once you know how it lights up, then you'll say, oh, okay, I have a common anode or a common cathode. There's not a little C or an I, but if you look inside, you can see how the pins are. But this one is hard to see because it's not transparent. This one has a diffuser, so all the colors blend in. There's other ones that they sell that they are transparent, and you can see by how they're connected which one is which. In this case, it's kind of hard to see in this picture,
Yes.
even if it's
I can
see-through,
tell.
because everything looks the same pretty much. But you could see the connection inside if you could see it through. Okay, so this is what we're going to connect in a little bit. You know how it looks, the legs, and so forth. We have a common cathode. So we're going to connect and light up a basic LED. We did that last week. We're going to do number 2 today. We're going to connect and light up an RGB LED. And we're going to hopefully use pulse width modulation as well to dim it, or make it brighter. That would be the ultimate thing to do today. All right, so let's go ahead and take a look at some stuff that you can do with the LEDs. I have some videos here that I want to show you. Can you ask, is there anybody that is watching on Periscope that has any questions so far? We're going to start showing some videos. Can you guys hear well? Please type something, a message, and Paulie, my cameraman, will be able to see it.
Holly.
Okay, if you get any messages, let me know. Here, let's take a look at this video. What some people do, and this is in South America. People create all these amazing ceilings, and they put RGB LED strips of LED lights. And let me show you, I'm gonna fast forward here. They're installing this, and you're gonna see the result in a couple seconds when they light them up. And they're hiding right behind there. See how the ceiling, they can create all these different moods and colors in the whole room just with RGB LED strips. Pretty awesome. Imagine having some of this in your room and changing the colors for whatever mood you feel like. Or it could be an alarm, connected to an alarm that wakes you up in the morning with music, and then the light just changes. Pretty nice and interesting. All that with microcontrollers. In this case, they're using rows of LED lights that are in there. Okay, let me pause on this one. I have a couple more to show you of some of the projects. This guy is in South America, and he makes those are the LED RGB strips, and he makes this sound that they respond to sound, and these are for clubs or areas. So you can even have this in your room. And let me show you, showing you how it looks. You're using an acrylic type of a makeup, and you can change the colors, and they go to the beat of the music, and they can change to them. Pretty cool to have at a club. Say and change it based on the beat. This would be like an equalizer type of thing. And then he explains. So there's tons of projects similar to this. Let's take a look at some other applications right here. This one is the same guy. I'm putting it in a disc and moving a disc with a motor. He just cut up a part of the disc, and now he's going to spin them and change the colors. See how it's turning? It's creating different colors. He just got a CD player, made a cut, put a light underneath, and creating all these awesome colors and stuff like that. And you can make this go to the beat of the music, however you like to as well. And that's using a motor and so forth. Now let's take a look at a couple other projects. This one is pretty nice. can change the whole color of your room by creating something like this. Right behind each of those pedals, there's an RGB LED. Incredible change in color and control of color.
This round color.
This would be nice at a restaurant maybe, people waiting or just relaxing, or a lobby. Or you could put a logo in front of it, company's name. You could have your own business just doing that. Okay, let's take a look at a couple more applications. See how it goes. Take a look at this one. You have a car or a motorcycle, you want it to go at night? You can make it look, change the color of it, how you like it. Alright, so a lot of applications, these are using mainly strips, but it's all starting from the same point of this RGB LED. Two more. Alright, very nice and crazy, but you can do almost anything. They incorporated a motor, an RGB LED spinning fast, and our last video of applications. Very nice. Those lights not only lighting up, but they're moving. In this case, they only used a couple of hues of the blue. But imagine the tone control that you can have once you can move and change the colors of red, green, and blue. Okay, so to complete our circuit right here, I'm going to go ahead and write the symbol of the here so you guys can see it. Here we have the resistor and the LED. In this case, we have three different LEDs. So we're going to have three resistors. There's another one. And three LEDs. We're going to have a red LED, a green, and a blue LED. This is basically the circuit that we're going to create. 3 resistors, and each one of these is a leg of that RGB. And then one of the legs connects to negative, the extra leg of the RGB LED. And the power is going to be given by the microcontroller. So instead of using a battery and just these 3, if I were to do just this will light up, this LED will light up, but you wouldn't have much control over them. It would just be steady on, and that's it. So if I want to do anything to control the brightness of these LEDs, I have to have a microcontroller that will control the supply and the pulse to this. So right here, I'm just going to put a box. This box is going to be the Arduino. Is going to control this. But instead of having one pin, you're going to have 3 pins connected to the Arduino. Each one controlling one light, one separate light. So 3 pins are going to control that from the Arduino, and then all the negatives are going to go to the same common ground in the Arduino, and we're going to define which of these 3 pins we're going to use to turn on or off. And we can turn on and off at different rates, different pulses, and make them brighter or dimmer. And all this combination will give us the different hues and different colors. So basically this is our circuit that we're going to create. But before we do that, we need to figure out what value are these resistors going to be. The Arduino will give out 5 volts on each of these legs maximum, and this particular LED has certain characteristics that we need to use to figure out the resistance value. The resistor is rated in ohms, so we need to find out how many ohms we need on these particular ones. So let's go ahead and take a look at some of the formulas, some of the calculations that we need to do. And this basic algebra, I created a calculator on Excel for us to do this. I'm going to open up that calculator, and with the calculator it's very easy, but we're going to go over the formula of it. And once we go through the formula, we'll be able to see exactly what we need to do. I'm going to put this calculator up so you can kind of understand, and I'm going to go over the calculation right here. If you want to follow me and get a piece of paper and pen, that way you can do your own calculations. It'll be better for you. That way you'll be able to follow it and you'll know for sure. Okay, so this is a current limiting resistor calculations for RGB LEDs. If we look at the specs of this RGB LED, it tells us that we need 2 volts on the red pin to work. The green needs 3.3, the blue needs 3.3. These are what is the voltage LED drop that is required for it to work. If we have a power supply of 4.5, in this case it's going to be 5 volts because coming from the Arduino, so I'm going to change that to 5 volts. Look how the resistance value changes at the end. It changes because I have a formula right there. So if I put 5 volts, these are the resistors values that we need there. Very simple. Now let's go ahead and do this on paper. In other words, do it right here on the board so you guys can see it. Basically what we have is a power supply. We'll do the calculation for one of them, and then the rest will be very easy. It will be very easy for us to do. Move this out of the way. Okay. So the formula is, we basically need the voltage of the supply minus the voltage forward we need to calculate that difference, and then this is going to be divided by the current, the forward current. So this comes from, current is abbreviated with I, so V equals IR. That's the basic formula, and we need to find the R. So if this is an algebraic expression, we need to isolate the R, so V divided by I is equal to R. This is what we're using right now. This is Kirchhoff's voltage law. Very simple. This voltage, though, is that difference that we have right here. The supply minus the forward voltage. That's this voltage. And the I, which is the current. Now, these values, all of these values comes from the spec sheets of the manufacturer that created these RGB LEDs. So in this case, I'll put right here what the specs are. In this case, the red.
She says, how was the current calculated again?
Okay. Well, we're not calculating the current, we're calculating the resistance. This is the formula right here, and I'll put it up here. V equals IR. Voltage equals current times resistance. Okay? Right now we're trying to find out what the R is. What is R? We know already the voltage and we know the current that will make that LED light up. So for that LED to light up, they have given us the following specs. In this case, I'm just going to draw one LED out of the three. They're telling us that for the red to work, based on the, as you can see in the calculator, we need 2 volts.
She says, where did the current value come from?
Comes from the specs of the RGB LED. So this RGB was made to work with 2 volts, and it has to work with a current of 0.050. Let's take a look here. Let me expand the calculator in amps. So 50 milliamps. This is amps. This was given to us, I'll put here given. This was given to us by the manufacturer to work. So this is the voltage. And this is the current. Let me erase this so you guys can see it. Okay.
John Paul, question.
Yes.
On the green and the blue, the 3.5 plus the 1.5 equals the 5. But on the red, the 2.5 plus just 2 does not equal 5.
This
Is
is
there
it.
something with that?
We have 5 voltage 2. Oh yeah. Let me see. There must be a problem with the formula here. Okay, that one works. That is correct. Let's take a look at this. It should be 3, right?
Yeah.
Okay. Yeah, I didn't put a formula there. I just wrote that.
Yeah.
So this needs to be 5
Minus 2 equals.
equal this cell minus that cell. That is correct. Thank you very much. Okay. So this information was given to us. all this by the manufacturer. And it's telling us for this LED to light up and not to heat up and not to blow up or burn, it needs a 2-volt forward voltage and needs to work on 50 amps, 0.050 amps of current. This is the same as saying 50 milliamps. But in our formula, everything has to be in the correct units. Volts have to be in volts, current has to be in amps, and resistance in ohms. So that's why when somebody says, oh, 50 milliamps, you need to convert it to amps by putting a 0 in front of it and a period. That's what it 50 milliamps is this. 60 milliamps would be, get it? Very easy, right?
I have a question.
Yes.
So 5 volts comes out of the digital outputs, right? Like with the Zeldas?
That's right. 5 volts coming out of the digital output of the Arduino,
Okay.
and that's our supply voltage. So right now, just like I mentioned, I'm going to put here the 5 volts that's coming out of the Arduino, right here. The voltage forward is this 2 volts, and the current 0.050. 50 milliamps. So what's happening basically is this. Let me just draw it here. Here you have a resistor, and here you have your LED. Let me do it in different colors so you can see it a little bit better. Those are in series.
What if we use the analog outputs? We see the incorrect voltage.
The analog will not work to create the dimming effect that we're trying to achieve because we're using pulse width modulation, and I'll explain later on what pulse width modulation is.
Okay.
But we're using the digital, and we're making the digital pulse and simulate something like the analog.
I see.
Yes, so that's what we will be doing. But right now, we're trying to figure out the value of this resistor. We already have it by the calculator, but I want you to see it so you can understand. So basically, you have a 5-volt supply right here coming to this circuit, and this needs to dissipate some of the voltage. The voltage needs to drop. So across here, we're going to drop out minus 3 volts. I'm not going to put minus, but 3 are going to drop out here and here. If 3 volts are dropped out by this resistor, then what we have? 2 left. Across here. And that's the 5. So in other words, for this to work, we need to drop out 3 volts out of here. So that's what we're doing here. 5 minus 2 is 3 volts. We're dropping out 3 with the resistor, and that's going to create only 2 volt drop here, and it's going to limit the current. So if I were to put, let's test you guys out. Looks very simple, right? Let's test you guys out. If I were to make this 10 volts, and you know that you need 2 volts here to work, how much voltage drop we need here for this to work? I'm starting with 10 volt supply. 8. We need 8, that's correct. So we're going to need, he's running out of okay. So we need 8 volts. When you get a 9 volt battery, right here, we need 7. That's correct. 7 to drop out, so we can have 2 working here. If we overdo this, then this will burn out. Very simple, right? So far, everybody understands. Any questions from anybody in Periscope? Okay. So we already done the calculation with our calculator. For the red, we have 5 volt supply coming from the Arduino. We need a 2 voltage LED drop. So the voltage drop across the limiting resistor is 3. There's 5 volts, 3 drop, we get 2. For that to happen, we need to have, and this is the forward current that we need to work in there, we need 60 ohm resistor. So that's the value that we need to find for the red. For the green, we need a 50 ohm resistor. And for the blue, we need another 50 ohm resistor. Okay? So those are the 3 resistors that we need. I have a bag full of resistors right here. Bags. It's a bag. And we need to find those 3. So, can you guys take a look in your computer, do a little bit of research right now on Google, and see and tell me what color. I'm going to go to what color of a resistor I need. If you notice the resistors, they have several bands around them, and based on the band, you can tell what value they are. So for example, let me get these ones out. I have all these resistors in here. I'm going to get one out. And these ones have colors around them. And the colors tells us what's the resistance, how many ohms this has the value. In the case of this one, I have a brown, black, yellow with a gold at the end. The one at the end, the gold, tells you the tolerance, how accurate it is by a percentage. The brown and the black and the yellow tells you how many ohms there is in the value of this resistor. So look on Google and see if you can find the chart and tell me what 3 colors make up a 60 ohm resistor. Let's start with the 60 ohm. I'll go ahead and look for the chart, and we'll go over that chart right now. Resistor value chart. Let's see what we come up with. There we go. Let's take a look at this one. It looks more comprehensive. Let's see if we can get a better. There we go. So there's different types of resistors. There's some that have 4 bands, 5 bands, and so forth. So in the case of the 60 ohms that we need, what color is equivalent to 6?
Blue.
Blue. So in our resistor, let's say this is our resistor right here. First one we need is a blue. What do we need next? Brown? Or black?
Black.
Black. If it's brown, it will be a 1. Blue, black.
Oh, because that's for the first 3 bands.
Oh, all of them black is 0. Either a 3rd digit, 2nd digit, okay. And then, that's it, right? And then the last one will have to be something of a multiplier.
Brown.
If it's a brown, it will be a 600 and
Yeah.
601.
You
So
need a
what
black.
would be the solution there?
Black, multiplying times 1.
Exactly, a black. So we need, and the tolerance will be the last one, times 1, which is 60. Blue, black, black. Let's take a look. There are other very interesting let's see, resistor calculator. All these awesome tools that are out there. I'm going to take a look. Let's close that up. There's a resistor calculator right there. Six. What's the other one?
0,
0,
1.
1. What does it say down here? 60 ohms. How beautiful. Life is so much easier with a computer. So if you didn't know, that's exactly what we need. And in this case, this tolerance is the gold, and the gold is 5%. If you get a resistor that has a gold band, that means it's very accurate. That means on 60, we'll be within 5% of 60, the value. So you will not get exactly 60, you'll get a little bit less than 60. And you can do your own calculation, how much would that be? So that's what we need to find. So the challenge right now is for you. I'm going to pass this on. I'm going to give you different bags. Some of them are already labeled, some of them are not. And for you guys to find blue, black, black. So. Blue, black, black. Start with this. Blue, black, black. Wow. And keep them nice and neat if you don't mind. That way, you guys here share this. Because we're going to put them back. So whoever finds the blue, black, black, the first, let us know.
Are we gonna learn how to do this in Fritzing?
Yes.
Awesome.
While you guys are doing that, I'm going to open FreeSync, which is one of the tools that I emailed you guys that we'll be using, and I'll create the circuit that we're going to connect today. How many of you downloaded FreeSync since last time? You have it? Excellent. If you haven't, it's a very awesome tool that you can use. So, while you guys look at that, I'm going to go ahead and open up a FreeSync.
We found one of them.
Oh, you found one? Just one?
Well, out of that set, you have between a green, black, black, and a blue, black, black. We have one.
You have one? How many you got there? 10?
Well, I found one that had black, black.
Yeah, it's brown.
That's brown, okay.
Yeah.
See if you can find blue, black, black. That's what we're looking at.
But of all the other
While you guys do that, I'll
denominations,
open up
black, black.
FreeSync. And,
Or green, black, black. Because when you green, black, black too.
well, it's green, black, black.
50.
50? Okay. Yeah, keep that one.
But it was a brown, black, black, so it's not even that.
Oh,
Either.
Well, you can put them in series and make.
yeah, we can do
a
series as well. That is
Yeah.
correct. Okay, so we're loading FreeSync, and here we're going to draw our schematic.
I knew it was a black, black.
So this is a program to do schematics?
This one does schematics, breadboard schematics, PCB, and you can also write the code in there.
So it's called FreeSync?
FreeSync, very, very nice, awesome software. Can you put it? All right. So we're going to go to the breadboard here. Our breadboard is a little bit smaller, and here on the breadboard you can choose the components that you're going to go ahead and add in there. This is a full breadboard. If you look at the size, I'm going to reduce it to a half. That's more like the one I have with me. But now, there's a half plus, and that has the coloring on the bands right here. If you take a look at mine, I have a blue and a red, a blue and a red. So this is is the exact breadboard that I have in my hand, drawn right here. Very nice and clear. Okay? I'm going to show you a couple things. You can move this around wherever you want to place it. The next thing I need is maybe what I'll do is I'll rotate this. I'm right-clicking, and I'm going to rotate 90 degrees clockwise. There we go. Rather vertically, like this. Now I'm going to put right here an Arduino board, and under core parts, I'm going to look for an Arduino board. I'm not sure how fast this is going. Let me take a look. See, Intel. This is the symbol for Arduino, and now all the Arduino boards are being loaded into here that exist in
How
there.
did you shrink the resolution?
The breadboard, right here, there's a little tab which says size. I put that half plus on the bottom. You see on the bottom, you have breadboard 1, properties,
Yeah.
size, half plus.
Oh, I see. Thank you.
No problem. Okay, so here are my Arduino boards. I have the Uno revision 3, that's the one I need. So I drag it, and it's right there. This is the same exact thing I have here in my hand, being drawn in FreeSync. My breadboard and my Arduino Uno. Pretty cool. So now, I'm going to connect, but I'm going to rotate my Arduino Uno so that I can have the pins that I need. So I need something like this, my digital pins, which are right here on this side. So I'm going to right click here, rotate counterclockwise 90 degrees. Boom, right there. You see that? Very nice. I'm going to connect to these pins, 9, 10, and 11. You see this squiggly line right here? I'm going to zoom in. These are pulse width modulation digital pins. These pins are digital, and they can create pulse width modulation, and that's what I need for what we're going to do on the second part of today. Hopefully we'll get to that part. Okay, so let me zoom out, move everything a little bit here, a little bit there. So now let me go ahead and find the RGB LED in here, and see if we can find that under search. RGB LED. There we go. We have several of them. Common cathode. What a luck. We found the correct one right here. I'm going to drag that right here. I'm going to rotate that clockwise. There we go. And I'm going to plug this in somewhere around here. Look what happens when I plug that in. Let me move that a little bit more. When that's plugged in, all these pins that are plugged into there are lit up. Let me take a look at this other one here. 6 legs, common anode. Okay, what about this? Common cathode. I'm not sure why this is not clicking. Usually these go inside the pins right here. I'm going to see if I can find another and see if there's any major difference in that.
Oh, you could always hook it in wrong, as in put it in.
Yeah, I'm not sure why it's staying off on the side.
That's fine. I like that.
It should actually go in there. Let me take a look. If the same thing happens with the other common anode. Okay, there we go. See what it is?
It won't go, yeah.
Yeah. It goes perfectly in this, like this, but if you connect them to the other side, let me rotate. Let's do 100 maybe. 90 degrees. Okay, so assume that these are in the holes. I'm not sure why it's not working on that way, because we need this to connect across. So we're going to put things across here. For example, this leg is connecting to all this. I'm going to zoom in here. This other leg is connecting to this line. This other leg is connecting to this line, but they're supposed to be inside the hole. And maybe the grate that we have is not, I think that's what it is. The grate that we have is not exactly doing anything. But it's okay. It'll still work. Let me check out the door.